So or AC source on the AC source E of t is equal to Em sin omega t. R and C are in series. The current flowing through the circuit is I of t, and there is no initial voltage across the capacitor. And at t is equal to 0, the switch is closed. Okay, so we'll find the expression for I of t. So we can write at t is equal to 0, the switch is closed. So this becomes like this, circle becomes like this. R and C becomes 1 by Cs. So E of t is Em sin omega t. So taking the Laplace transform, this becomes E of s, and E of s will be equal to Em. The Laplace transform of sin omega t is omega divided by s square plus omega square. Okay, so Em into omega divided by s square plus omega square is E of s. This is the resistance R, and this is the capacitance we are transforming to S domain. So it is 1 by Cs, and the current flowing through the circuit is I of s. So we can write the equation. So this becomes E of s is equal to I of s into R plus 1 by Cs into I of s. So applying KVL to this loop, we can write it like this. So at this instant, we are considering the top as plus and bottom as negative. So this becomes E of s is equal to I of s into R plus 1 by Cs into I of s. So this can be written as E of s is equal to I of s into R plus 1 by Cs. So E of s is equal to I of s into R plus 1 by Cs. So this can be written as I of s is equal to, so we are going to find what is I of t. So I of s is equal to E of s divided by R plus 1 by Cs. So what I'm going to do next is I'm going to take R by s outside. So this becomes I of s is equal to E of s divided by R by s into S, so this becomes R itself plus 1 by RC. So this becomes S plus 1 by RC form. So I'm taking R by S outside. So the this becomes S, so that R by S into S is R itself, and 1 by RC into R by S is 1 by CS. So this is similar to this thing. So E of S divided by R plus into R by S into S plus 1 by RC. Now we know what is E of S. E of S is Em divided by S square plus omega square. So E of S is Em sin omega t. Em sin omega t is Em into omega divided by S square plus omega square into, I'm taking this to the numerator, so this becomes S by R divided by S plus 1 by RC. So we'll get this as omega Em divided by S square plus omega square into, I'm taking this R by S to the numerator, so S by R divided by S plus 1 by RC. Here this term is E of S, the Laplace transform of E of S is Em into omega divided by S square plus omega square. The function we have considered is E of t is equal to Em sin omega t. So the Laplace transform of E of t is E of S. So sin omega to the Laplace transform omega divided by S square plus omega square. So we'll get I of S like this. Now what I'm going to do next is, so we can rearrange this like omega Em by R into S divided by S plus 1 by RC into S square plus omega square. Okay, now we have to use the partial fraction expansion. So by partial fraction expansion technique, the above equation of I of S, this is I of S. So I can write I of S as like this. So omega Em by R into S divided by S plus 1 by RC into S square plus omega square can be written as A by S plus 1 by RC, and this is having complex roots, so this can be written as BS plus C. So A plus Bs plus C divided by S square plus omega square. Now our task is to find what is the value of A, B and C. So this is partial fraction expansion lady. So A by S plus 1 by RC plus Bs plus C divided by S square plus omega square. So now we have to find what is A, B and C. So in order to find A, we can write A is equal to S plus 1 by RC into F of S. This is F of S at S is equal to minus 1 by RC. Applying the method of residues, we can write it like omega Em by R into S divided by F of S into S plus 1 by RC into S square plus omega square. This term into S plus 1 by RC at S is equal to minus 1 by RC. Okay, this is how we'll find A. So this S plus 1 by RC and this S plus 1 by RC gets cancelled. So I can write this like omega Em by R into S is minus 1 by RC here. So I can substitute minus 1 by RC over here divided by minus 1 by RC the whole square plus omega square. So that is in the denominator. So this can be written as minus omega Em divided by R square C divided by, I'm going to take omega square by R square outside. So this becomes omega square by R square into 1 by omega square C square plus R square. So that means omega square by R square into 1 by omega square C square is nothing but 1 by R square C square. That is the square of this 1 by R square C square. That is omega square by R square into 1 by omega square C square. You will get it as 1 by R square C square. And this term is omega square R square divided by R square. You will get it as omega square. So from this denominator, I am taking omega square by R square outside. So inside the bracket, the terms will be like this 1 by omega square C square plus R square. So this can be written as so I can cancel this R square and omega. So R square gets cancelled and 1 omega gets cancelled. So this becomes minus Em divided by omega C divided by 1 by C square omega square plus R square. Or okay, I can write it as R square plus 1 by omega C the whole square. And so what I have done is I have cancelled this omega and R square. So the expression now becomes minus Em by omega C divided by R square plus 1 by C omega the whole square. So you all know that for an RC circuit, the impedance Z is equal to root of R square plus XC square. RC circuit impedance Z is the root of R square plus XC square, where XC is 1 by C omega. So this can be written as root of R square plus 1 by C omega the whole square. So this is nothing but Z square. So I can write instead of R square plus 1 by C omega the whole square, I can write it as Z square. Is there any problem? Okay, so I can write here minus Em divided by omega C Z square. So this is A. So we have got the expression for A. A is equal to minus Em divided by omega C Z square. And what we are going to do next is, this is our expression 1. I am going to multiply both the left hand side and the right hand side by this denominator S plus 1 by RC into S square plus omega square. So I will get it as omega Em by R into S is equal to A into S square plus omega square plus Bs plus C into S plus 1 by RC. Now, equation 1 in the LHS, right, RHS, I am going to multiply with S plus 1 by RC into S square plus omega square. So, multiplying LHS and RHS of equation 1 by, what was our term? S plus 1 by RC into S square plus omega square. S plus 1 by RC into S square plus omega square. So I'll get it as omega EM by R into S is equal to A into S square plus omega square plus BS plus C into S plus 1 by RC. Now we have to find B and C. So for that, I'm going to open these brackets. So omega EM by R into S is equal to A S square plus A omega square plus B S square plus B by RC into S plus CS plus C by RC. Okay. So next what can we, so this ഇതിനകത്ത് നമുക്ക് S square coefficients ഒരുമിച്ചാക്കാം, S coefficients ഒരുമിച്ചാക്കാം, constant term ഒരുമിച്ച് എഴുതാം. So we'll get this like omega EM by R into S is equal to A plus B into S square, okay, plus B by RC into S plus CS. So this can be written as B by RC plus C into S plus A omega square plus C by RC. So next what we are going to do is we are going to equate the coefficients of S square. Equating coefficients of S square on LHS and RHS. So on the LHS, there is no coefficient of S square, so it is equal to 0. And on the RHS, the coefficient of S square is A plus B. So I can write A plus B is equal to 0. That is equating the coefficient of S square. I can write A plus B is equal to 0. So that means B is equal to minus A. So we have got the value of A. A is minus EM by omega C Z square. So B is what? B is minus of minus. So it is EM by omega C Z square. So B is minus A, that is equal to EM divided by omega C Z square. So we have got what is B. Now we have to find C. For that we can equate the coefficients of S. So equating coefficient of S. So let this be our second equation. Second equation. Now what we are going to do next is we are going to equate the coefficient of S. So our LHS is omega EM by R. So we can write omega EM by R is equal to B by RC plus C. So I will get C as omega EM by R minus B by RC. And we know the value of B. So we can substitute that over here. So this can be written as omega EM by R minus B is EM by omega C Z square. So EM divided by omega C Z square into 1 by RC. Okay. So I'm taking the LCM, that is R C omega Z square. So the denominator is R C square omega Z square, and here it becomes EM into, so I have to multiply this with omega EM with omega C square Z square. This becomes omega square C square Z square. So omega EM into omega, so I'll write it like that itself. So there shouldn't be any confusion. So this is EM omega into, so here there is one omega C square Z square, and here it is minus EM omega into omega C square Z square minus EM divided by R C square R C square Z square omega. Okay. So we have taken the LCM and written, I have written like this. Now this can be written as, I'm taking this EM on the numerator outside, EM into omega square C square Z square minus 1 divided by omega into R C square Z square. So I have taken EM outside. So EM into omega square C square Z square minus 1 divided by omega R C square Z square. So here, next what I'm going to do was EM into, I'm going to take this omega square C square outside. So our expression becomes omega square C square into R square plus 1 by omega square C square minus 1 divided by omega R C square Z square. So instead of Z square, I have given R square plus 1 by omega square C square. So this expression becomes like this, EM into omega square C square, R square plus 1 by C square omega square minus 1 divided by omega RC square Z square. Next is, this can be written as EM into R square C square omega square plus 1 minus 1 divided by omega R C square Z square. So I have multiplied this with omega square C square. So this becomes R square C square omega square plus this omega square C square, and this gets cancelled. So plus 1 minus 1. So EM into R square C square omega square plus 1 minus 1 is 0 divided by omega R C square Z square. So this can be written as EM R square C square omega square divided by omega R C square Z square. So we can cancel this omega and C square and 1 R. So our expression becomes, and this C square. So our expression becomes EM R omega divided by Z square. So this can be written as EM R omega divided by Z square. So this is our C. So we have got C now. If you have any doubt, you can ask me. So we have found the values of A, B and C. So A is minus EM by omega C Z square. B is EM by omega C Z square. and C is Em r omega divided by Z square. So we can now substitute these values of A, B and C in equation number 1. So this is our equation, that is omega Em by r into S divided by S plus 1 by Rc into S square plus omega square is equal to this thing. So this is the partial fraction expansion. This is the partial fraction expansion of I of S. So now we can write I of S as I of S is equal to A divided by S plus 1 by Rc plus Bs plus C divided by S square plus omega square. And we know the values of A, B and C, and we can substitute that over here. So our expression for I of S becomes substituting A, B and C in equation 1, we'll get I of S. So I of S is equal to A by S plus 1 by Rc, and A is minus Em by omega C Z square. So this becomes minus Em by omega C Z square divided by S plus 1 by Rc plus Bs plus C, and our B is Em by omega C Z square S plus C is omega R Em divided by Z square. So this is Bs plus C divided by, the denominator was, in equation 1, the denominator was S square plus omega square. So we are writing S square plus omega square. So now this is our I of S. So this can be written as minus Em by omega C Z square into 1 by S plus 1 by Rc plus Em by omega C Z square into S by S square plus omega square plus R Em divided by Z square into omega by S square plus omega square. Okay, now we can take the inverse Laplace transform. Taking inverse Laplace transform. So now we want what is I of t. So we are going to take the inverse Laplace transform of this particular expression. So we'll get I of t. So I of t will be equal to minus, so there was a minus over here. So I of t is equal to minus Em by omega C Z square into Laplace inverse of 1 by S plus 1 by Rc. So that will be equal to 1 by S plus 1 by Rc Laplace inverse inverse Laplace transform e raised to minus 1 by Rc into t plus Em by omega C Z square S by S square plus omega square the inverse Laplace transform cos omega t. So cos omega t plus Rem divided by Z square into omega by S square plus omega square the Laplace transform sin omega t. Okay, so we have taken the inverse Laplace transform. I of t is equal to minus Em by omega C Z square into e raised to minus t by Rc plus Em by omega C Z square into, this is the Laplace inverse Laplace transform of cos omega t. So inverse Laplace transform of this is cos omega t and this is sin omega t. So we have written all those things. Now we can write this as, this is equal to minus Em by omega C Z square e raised to minus t by Rc plus, I am taking Em by Z square outside, this becomes Em by Z square into 1 by omega C cos omega t plus R sin omega t. So this is R sin omega t. So this is our expression. Now we can check the impedance triangle. So we have to substitute the values for cos omega t and we have to substitute the values for 1 by omega c and R. So we can take the impedance triangle. So as you all know, the impedance triangle for an RC circuit will be like this. This is R, this is XC, and this is Z. Okay, and this is the angle between voltage and current, which is equal to phi. So this is V is equal to I into Z. This is V is equal to I into R. This is V is equal to I into XC. So we can write this as R, XC and Z. This is the impedance triangle, and the angle between voltage and current will be equal to phi, that is marked here. So from this impedance triangle, it is clear that tan phi is equal to opposite side by adjacent side, which is equal to XC by R, or I can write phi is equal to tan inverse XC by R, and from this cos phi is equal to R by Z, or I can write R is equal to Z cos phi, and sin phi is equal to XC by Z, or I can write XC is equal to Z sin phi. What is XC? XC is nothing but 1 by C omega. So 1 by C omega is equal to Z sin phi. So in the above expression I of t, instead of 1 by omega c and r, I can substitute, instead of 1 by omega c, I can substitute Z sin phi. Instead of r, I can substitute Z cos phi. So we are rewriting this equation I of t. So I of t is equal to minus Em by omega c Z square e raised to minus t by rc plus Em by Z square into 1 by omega c is Z sin phi. So Z sin phi cos omega t plus R is Z cos phi. So Z cos phi sin omega t. So I can take this Z outside in the next step. So this can be written as minus Em by omega c Z square e raised to minus t by rc plus Em by Z into, this can be written as Z is taken outside, so Z by Z square is Z in the denominator. So sin phi cos omega t plus cos phi sin omega t. So sin phi cos omega t plus cos phi sin omega t. So this is sin A cos B plus cos A sin B form. So sin A cos B plus cos A sin B is nothing but sin of A plus B. So this can be written as minus Em by omega c Z square into e raised to minus t by rc plus Em by Z into, so I am taking as sin A plus B, I am taking A as omega t. So this can be written as sin of omega t plus phi. So minus Em by omega c Z square e raised to minus t by rc plus Em by Z sin of omega t plus phi. So this is I of t. So this is our final expression. I of t is equal to minus Em by omega c Z square e raised to minus t by rc plus Em by Z sin omega t plus phi. So this is the transient part of the equation. So it contains e raised to minus t by rc. So this is the transient part and this is the steady state part. So where we can write Z is equal to, here Z is equal to root of r square plus xc square, or r square plus 1 by c omega the whole square, and here we are having a phi, and that value phi is equal to tan inverse xc by r, or 1 by c omega divided by r. So this is the expression for current for an RC circuit excited by an AC source. I of t is equal to minus Em by omega c z square e raised to minus t by RC plus Em by z into sine of omega t plus phi. So it has two parts. One is the transient part and this is the steady state part. From the equation itself, it is clear that this term is the transient part and this is the steady state part. Okay. So that's the derivation for RC circuit excited by AC source. Okay. RL circuit excited by AC നിങ്ങൾ കണ്ടല്ലോ അല്ലേ? Have you seen the video on RL circuit excited by AC source? Answer me.
Yes, ma'am.
ഇപ്പോൾ ചെയ്ത ഡെറിവേഷനിൽ എന്തെങ്കിലും പ്രശ്നമുണ്ടോ?
ഇല്ല, ma'am.
Okay.